In June 2023, the world watched a desperate search unfold in the North Atlantic. A small submersible named Titan had vanished on its way down to the wreck of the Titanic. For days, the story looked like a rescue mission against the clock. Oxygen estimates dominated the headlines. Every hour felt critical. But the final investigations showed something far worse. This was not a random disaster in deep water. It was not a single unlucky failure. According to the U.S. National Transportation Safety Board and the U.S. Coast Guard, the loss of Titan came from an inadequate engineering process, a damaged pressure vessel, flawed monitoring, ignored warning signs, and a company that kept operating outside the safeguards the rest of the industry considered normal. This is the story of how a vehicle built to survive one of the harshest environments on Earth was already on borrowed time long before its final dive. OceanGate's Titan was a 22-foot submersible designed to carry 5 people to the wreck of the Titanic, nearly 3,980 meters below the surface. At that depth, the pressure is immense, more than 5,500 pounds per square inch. The entire job of the pressure vessel was simple in theory and brutal in practice. Keep the ocean out and keep the people inside alive. The most critical part of Titan was its pressure hull. The 2020 vessel used a thick carbon fiber composite cylinder joined to titanium rings and capped with titanium domes. That choice made Titan unusual. Traditional deep-diving human-occupied submersibles overwhelmingly rely on metals such as titanium or steel for the pressure boundary because repeated deep cycles are unforgiving and the failure mode is absolute. OceanGate chose a different path. Lighter, more experimental, more ambitious, and far less proven for this kind of service. That decision sits at the center of everything that followed. The disaster was not caused by carbon fiber alone. The investigations point to a deeper systems failure. OceanGate never established the real strength and durability of the pressure vessel it was putting people inside. The NTSB concluded that OceanGate's engineering process was inadequate and that the pressure vessel contained multiple anomalies and failed to meet necessary strength and durability requirements. In other words, the company was not just taking risk. It was operating without truly knowing how much risk it had built into the vehicle. Investigators later found defects in the composite structure itself. The recovered material and production samples showed porosity between layers, voids in adhesive, a pre-existing disbond between bonded layers, and wrinkles or waviness in the carbon fiber. Those are not cosmetic imperfections. In a structure that must survive repeated extreme external pressure, those flaws become stress concentrators, damage initiators, and eventually crack growth pathways. This is the part many people miss. The fatal implosion happened in seconds, but the real failure had been developing for years in design choices, manufacturing defects, testing assumptions, and operational decisions. Another major warning sign was classification. Classification societies exist to independently review designs, witness testing, and verify that a vessel meets recognized standards. According to the NTSB, OceanGate originally intended to class Titan through a major classification society, but that effort was abandoned in 2018. Former personnel told investigators that the CEO decided classing would take too long, and industry members warned that OceanGate's experimental approach could lead to outcomes ranging from minor to catastrophic. That matters because independent review is exactly what is supposed to stop a company from believing its own assumptions. It forces evidence. It forces documentation. It forces proof under scrutiny. Instead, OceanGate moved forward without Titan being classed, without a flag state inspection framework, and without the kind of third-party certification that might have forced hard questions before paying passengers were taken to nearly 4,000 meters. The NTSB states plainly that Titan was not registered in any U.S. state, not documented by the U.S. National Vessel Documentation Center, and not inspected by any flag state. A system designed to resist external challenge had become a system that filtered it out. The investigations identified a critical turning point, Dive 80 in July 2022. During that dive, OceanGate personnel heard a loud bang. Data from the submersible's monitoring system showed a burst of acoustic activity and a sudden jump in strain readings. When the NTSB reanalyzed the data, it found that the hull's strain response changed after that event. Before Dive 80, the strain behavior was linear. After Dive 80, some sensors showed non-linear behavior near the surface, a pattern the NTSB said was consistent with one or more delaminations between bonded layers of the pressure vessel. That is the moment the story changes from dangerous design to damaged vehicle. The NTSB concluded that the pressure vessel likely sustained damage after dive 80 in the form of one or more delaminations, and that these likely formed from voids between the cylinder's bonded layers. The vehicle then continued diving. According to the NTSB, additional damage of unknown origin occurred after dive 82, further weakening the structure until a local buckling failure caused the final implosion on dive 88. That means the final dive was not the first time Titan failed. It was the last time. OceanGate promoted what it called a real-time monitoring system. In theory, that sounds reassuring. The vessel carried acoustic emission sensors and strain gauges intended to monitor the health of the pressure hull during operations. But the NTSB found that OceanGate's analysis of that data was flawed, and that the company failed to recognize that the vessel needed to be removed from service after dive 80. This is one of the most important lessons in the entire case. A bad safety system can be more dangerous than no safety system at all if it creates false confidence. Once leadership believes a dashboard can detect catastrophic failure in time, the dashboard stops being a tool and starts becoming an excuse. But deep ocean pressure hull failure does not unfold on human timescales. When the structure finally gives way, there is no corrective action, no escape procedure, no recovery maneuver, no second chance. You do not monitor your way out of a pressure hull that should never have been in service. On June 18, 2023, Titan began descending from the support vessel Polar Prince toward the Titanic wreck. The dive was expected to take around 8 hours in total. Communication checks began shortly after descent. At 10:47 a.m. local time, while Titan was at a depth of about 11,032 feet, around 3,363 meters, OceanGate received a message from the submersible saying it was dropping 2 weights, which was a standard step to slow descent. 1 minute later, the surface vessel sent a reply. No response came back. At first, the crew did not treat the silence as an emergency. According to the NTSB, communication losses had happened on previous missions, and the captain of the Polar Prince later said this was not initially perceived as an emergency by OceanGate. That detail matters because it shows how abnormal behavior had already been normalized. In a high-risk system, repeated non-catastrophic anomalies can teach operators the wrong lesson, that silence is routine, that warnings are noise, that the system is more robust than it really is. But at 10:47, the real event had already happened. The NTSB determined that this was the moment the pressure hull failed and the submersible imploded. All 5 people on board died instantly. After contact was lost, the event unfolded publicly as a search and rescue emergency. Aircraft, ships, sonar buoys, and remotely operated vehicles were mobilized. The wreckage was eventually located near the Titanic, roughly 500 meters from the bow. The field included major structural components, such as the tail cone and both titanium domes. There were no survivors. The NTSB later found that OceanGate's emergency planning was inadequate. Although the company's execution plan listed search and rescue contacts, it did not require rescue assets to be notified in advance or staged on site before dives. The investigators concluded that had OceanGate followed existing guidance, the wreckage likely would have been found sooner, even though no rescue would have been possible because of the catastrophic nature of the implosion. So even the final public phase of the tragedy carried the same pattern as the engineering story. Improvisation where there should have been preparation. It is tempting to reduce Titan to one headline: carbon fiber, or Stockton rush, or anti-regulation bravado. But those are only fragments. The full picture is a classic system failure. A novel design was pushed into an extreme environment without proving real structural durability. Independent oversight was avoided. Industry concerns existed. Damage signals appeared. Monitoring data was misread. Operations continued. Emergency planning remained weak. And all of it happened inside a culture the Coast Guard later described as including toxic workplace dynamics and weak processes around certification, maintenance, and inspection. That is how catastrophic failures usually work. Not as one dramatic mistake, but as a chain of tolerated compromises. The implosion of Titan was shocking because of where it happened. In darkness, in deep ocean, above the most famous shipwreck on Earth. But the real lesson is much less cinematic and much more uncomfortable. This disaster was built in meeting rooms, in design reviews, in abandoned safeguards, in unverified assumptions, and in the decision to keep going after the system had already started to warn them. In engineering, nature does not negotiate. The ocean does not care about branding, confidence, or innovation language. At 3,800 meters, your design is either right or it is gone. And in the case of Titan, the final investigations make one thing brutally clear. The implosion happened in an instant. The failure took years. This is how systems really fail.